Good day, everyone. Thank you for attending this session of ITSA 365 IT Security Talks with Tresorit, facilitated by Encryption Europe. My name is James Briscoe, and I am the Policy and Outreach Officer at Encryption Europe, a Luxembourg-based industry alliance of European SMEs and midcaps that champions strong encryption and encryption best practices. Our goal is to promote and protect encryption technologies in Europe to secure the privacy and security of all Europeans. Today, I am excited to introduce you to Tresorit, a leading provider of secure, end-to-end encrypted cloud storage solutions and an influential member of the Alliance. Tresorit's success and commitment to securing and protecting encryption technologies are exemplary and align with the mission of Encryption Europe, as demonstrated by their continued participation in our expert webinars and events like Global Encryption Day. In this webinar, Tresorit's Chief Data and Compliance Officer and co-founder, Sylvester Sebeni, will discuss the finer details of true end-to-end encryption, how zero knowledge can improve your sleep, and how only ease of use can eliminate the human factor. I'd like to take this opportunity also to thank ITSA 365 for hosting this event and providing a platform for industry leaders to come together and discuss the importance of encryption and security. By presenting this event, Tresorit is demonstrating its commitment to educating people about encryption and promoting best practices in data security. And with that, I will hand over to Sylvester.
Thank you, James. So today we're going to talk about end-to-end encryption and how it really took over the world in ways that a lot of us haven't seen or realized. But then also talk about what its promises are and when it doesn't always deliver on this promise. So we're going to jump straight into the agenda of today. First, what we're going to talk about is what end-to-end encryption is and how it compares to traditional cloud security. And then I would like to share with you a little bit of the timeline of how end-to-end encrypted products and when they were launched. And then looking at the space today of what is out there that we use in our day-to-day lives and what is available for businesses to use as well. And then we're going to go into a case study, looking at a data breach that happened in the near past and evaluating what different organizations could do to remedy the particular scenario, and then coming to a few conclusions of what the remaining risks there still are when you are using an end-to-end encrypted product and what remediations should be done on the users and on the service provider side. So what is end-to-end encryption? Before we dive into what end-to-end encryption is, I think it is important to understand what traditional cloud security looks like. When you are sharing a file, for example, between two users over the internet, what happens today is that on your machine, you have that file that is probably quite confidential, and you're uploading it to the server. And this channel, it's protected. This is what we use day to day when you connect to your bank, HTTPS, SSL, TLS. These are the technologies that are used to protect this channel. So anybody who has access to this channel will not be able to read its contents. That's very great. This is what gives us a secure connection and communication with our banks, for example. Now the server receives the file and the server can see this file. So anybody who has access to that server can also see the file. This file would then be put onto some storage in an encrypted manner. So anybody who is changing the hard disks on that storage, a technician or anything like that, would have no access to the file, which again is great. This is what we call at-rest encryption. And when the recipient would like to retrieve the file, they request it from the server requests it from the storage, decrypts it, and then sends it to the recipient. Now, in this scenario, anybody who controls the server, let this be a hacker, an admin, three-letter agencies trying to access the data, they all have a way to retrieve this file once it goes onto the service provider's systems. Now, contrary to this, when you're talking about an end-to-end encrypted architecture, the file is encrypted on the client side and only then sent to the server, put onto storage, retrieved from the server, and the recipient decrypts the file on the client, meaning in the browser or the desktop application that they are using. And one very important thing is that the keys are also managed by the end users, guaranteeing that nobody other than these two users or their machines are able to decrypt the contents. So a few properties of end-to-end encryption are the following. As we've already discussed, the most important property is that the information that is being transmitted between users are encrypted once it leaves the sender's device and remains encrypted all the way until it receives the recipient. And the key management is also performed by the endpoints. So there is no central key server or anything like that, like in other DRM-like solutions that distribute keys. The endpoints manage the keys. This is very important. And the encryption and decryption happens on those endpoints. Now, the server does not see any content, keys, or passwords. They only store the encrypted content, encrypted keys used to decrypt the content, and public keys and certificates that is used to share keys between users. A little bit of history or recent history about end-to-end encrypted products. Here's a long list of products a lot of you may know. One of the foundations for end-to-end encrypted technology is PGP, which is an email extension built on top of email. And the way this worked was that users would share public keys with each other and then send emails encrypted with that public key that then the other recipient could decrypt using their browser extensions and very specific tools. Later on in the late 2000s or the late 2010s, along came a few file syncing sharing companies like Tresorit, which is a file storage company like ourselves. You also have iMessage coming along with the likes of Apple, which is quite limited only between Apple devices. And probably the most widespread used application, WhatsApp, which has end-to-end encryption built in. Of course, there are some privacy concerns behind it with the metadata, but if we just look at the architecture itself, the messages themselves that we send between our friends cannot be decrypted by anybody else, only the people we are messaging. And later on, going into the business space, Zoom has listened at the beginning of the pandemic with all their security concerns. They've listened to those concerns, and the foolproof solution for those concerns was to implement end-to-end encryption, which came out later that year. I take my hats off to Zoom in implementing this. Microsoft Teams is also there, though lagging behind, with their solution only working with one-to-one conversations. So the minute you have more than two people in a conversations, the end-to-end encryption is disabled, or I would rather say not implemented, because it is more complex to implement. And this is one thing that we all see, that there are a lot of companies that take shortcuts when implementing end-to-end encryption and only do the most basic requirements of crypto engineering. And we'll see later on in our case study. Now, the question is usually in IT, when you have a company that comes up with a new idea, usually that they take away all the winnings or a technology. But in this case, it was not the case. That PGP is only used by a few techies, while WhatsApp is used by about 2 billion people in the world. And there's a big difference. And over here, the reason behind this, in our opinion, is just the usability. The industry has for a long time had this narrative that the easier to use something is, the less secure it is, or the more secure it is, that must be harder to use and accept these obstacles when using something in the name of security. We at Tresoriat think this is a very flawed approach to IT, because when you make something unusable, people will find a way around it. They will not use it. And that is the breeding ground for shadow IT to appear in an organization that will lead to uncontrolled data storage and information leakage. So an encryption solution, a security solution, should not be an add-on to an existing product that's unsecure. But when we create IT products, or anything in general for that matter, security should be part of the planning process at the very beginning. And that is how we designed Tresoriat from day one, to make it usable and secure. And therefore you had the same feature set as a general product, just encrypted and designed from day one so that these features work, because you have to implement it differently when you're implementing these type of solutions, since you cannot rely on the server to make complex calculations. Everything has to be done on the client side. And that is why I predict that email as we know it today will never be secure. To make it secure, you have to replace it with a different platform. Of course, that's going to be really, really hard since it's so much entrenched into our daily lives. We have a lot of patchwork around it to make it more secure. But that is why email is one of the biggest risks to companies today. So the moral of the story here is, do not sacrifice on ease of use when implementing any IT solution, because it will just lead to less security. Looking at the communication space today, I thought it would be interesting to highlight what tools there are out there that we use day to day, and which of these tools have end-to-end encryption in them, and with what limitations. Wanted to start off with the chat space. This is a space that we use a lot in our daily lives, probably usually as private citizens, because these applications are not so much a part of business use cases, but we'll get to business solutions later on. So looking at these widely used applications, a lot of them have end-to-end encryption, like iMessage, WhatsApp, Wire, and Signal. Google Chat, unfortunately, doesn't have any end-to-end encryption options. Telegram, similarly to Teams, only has a one-to-one channel that is optional, where it is end-to-end encrypted. And similar to that, Facebook Messenger, end-to-end encryption is an optional tool where you can turn it on when you're talking to people. And my belief there is that if something is not default, unfortunately, it's not going to be used by the vast majority of users. And of course, Facebook does not want people going off their platform, so the option is there so that they can say that if somebody wants it, then they have it. But unfortunately, still probably 90+% of messages via Messenger are still not end-to-end encrypted. Talking about the video conference solutions, I've already touched on those. Three of the big or widely used application all support end-to-end encryption. So I'm really happy that in this space, end-to-end encryption is really taking off. And especially if you have high-profile board meetings, using an end-to-end encrypted Zoom or Cisco WebEx solution is definitely the approach you would like to take. Finally, there is file sharing, software as a service file sharing solutions for businesses. And over here, the situation is slightly different, where there's only one player that's end-to-end encrypted, and the other widely used players are not. Now, when we're talking about file sharing versus messaging, there's one huge difference is the type of data that is being transferred. When you have messages or voice, that data lives only for a very short time. So the key management has only need to be done once for that particular time. And next time you have a conversation, you can redo the key management and you don't need to worry about accessing old data. Now, when you're talking about a file sharing solution and password managers, that's the next section, you have to be able to access old data because that's very valuable data to you. You do not want to lose all the data that you worked on a week ago or yesterday. And over here, the key management is slightly more complex when you have ever-changing groups and ever-changing files. And on to password managers. Now, password managers are probably the most critical because that's where you store all your secrets, not necessarily just passwords, but keys for deployment applications and anything like that. And of course, we at Trezorit highly recommend that you use some form of password management because there's just simply no way that for the hundreds of accounts that you need to access on a regular basis, you can remember unique passwords. Now, choosing a password manager is slightly tricky, as we have also recently noticed. They all have end-to-end encryption, which is great. I just wanted to highlight KeePass over here, which is one of the most widely used offline password management applications. But the drawback to KeePass is that it's not easy to share secrets with other people in your organization when you're talking about a business use case. All the rest are software as a service based approach that all have end-to-end encryption. But two of these that are more for consumers, the browser-based and Apple Keychain, you do not have sharing. So I would also highlight that those are not really suitable for a business use case. All the rest are very similar in implementation and performance. One key difference is the way that the master password or the master key is derived. Most of these are derived from the password, and that master key is the key that's used to decrypt all the rest of your passwords that you're storing in your vault, so to say. Now, two exceptions to this is the Apple Keychain and 1Password, where there is no master password, or the master password is more just like a PIN. The master key is stored on the device, and if you want to log into a completely new device, your password is not enough. You either need a recovery key, or you need another device that's already logged in. And the next question is, what happens when there is a data breach, when you have an end-to-end encrypted solution? The promise over here is that since the service provider has no access to the data, theoretically, there should be no issue when all the data is leaked, if you have a strong password, of course. Now, with this password manager breach that has happened in the past, most of you, I'm sure, have heard that LastPass has quite a large data breach. We went ahead and thought, what should companies do in this particular scenario? Now, we're not going to worry about all the unencrypted data like billing data. That data is usually pretty public anyway. You can find the billing data for any organization. And that's outside the topic of today's talk. But what we would like to talk about today is the encrypted content and what attackers can do with that encrypted content. So if you have a strong password and you're a single user, in theory, there should be no issue. But of course, what if one of your employees has a weak password that is prone to brute forcing? Let's say it's only 9 characters long, and after some time, somebody's going to start trying, and they're going to have access to all your passwords. No problem. What you can do, you change all the master passwords and you change all the passwords in your vault. This, of course, takes a lot of effort, but one would think that this solves the risk that even if the password is cracked for this leaked data, they only have access to the old passwords that don't work anymore. Now, the issue with this is that going back to implementation of the cryptography, what we've seen widely in the industry for a lot of providers, they still use the same keys. There is no key rotation. And what this means is that this part of the chart has been leaked. So the old password, its stretched form, of course the password itself was not leaked, but the stretched form of the password was leaked, the encryption key, and the encrypted passwords. Now, if somebody hacks this old password, they start testing and find one that works, then they can have access to the old keys. Now, you were proactive, you were a very diligent admin and made sure that all the passwords were changed. You would think that you are fine now. Now, the issue is that what happened in the background was a new password was set with a new stretched key, and unfortunately, this key is still the same. So you've protected all these new passwords with this same key. Now, if there is another data breach, then if this old password was hacked, they have access to the key, they have immediate access to all your changed password, which is not what you would expect. And this is not just true for hacked passwords, but let's say you have an administrator that was removed from the group. They had access to all the passwords. You were, again, a very diligent admin and you changed all the passwords, but there was a data breach, and using their old passwords, they have access to the key and immediate access to your new passwords. And there is already an option for the old administrator to blackmail the organization, which I think is a huge risk. So removed employees, broken accounts, or even broken accounts of removed employees, which I think is the highest risk, break the promise, I think, of end-to-end encryption, because in this scenario, if you've changed everything, you should believe that this key is also changed. So now the answer to this, of course, is to rotate these keys and create a new key when you're creating new passwords. And with this setup, once you've rotated all the pairs, when you change a password, or just by changing these keys every now and then, or when someone is removed from the group, you can solve this scenario from the software provider side. Now, of course, that's implementation and makes it work more complex, but to do encryption right, you have to take these steps. So in conclusion, the promise of end-to-end encryption is that when the data providers hackers will not have access to your data, but that's only true if you have strong passwords. And the risks are that in case you have weak passwords, these can be potentially brute forced. If a key rotation is not implemented correctly, using old passwords, new secrets can be reached via old keys. And there's 4 basic ways you can remediate this. Of course, use a strong password. That's the obvious one here. But if you're an organization, that's not necessarily feasible. And if you're a software provider doing end-to-end encryption, then use strong password stretching algorithms that make it harder for hackers to break these passwords, implement periodic key rotations, and do immediate key rotations after any security events such as a breach or password changes by the user. So that was our talk for today. I hope everyone could take something away from this talk, and I'm open to listen to any questions.
How do you define suitable for business?
How do you define suitable for business with password managers? So one very simple feature requirement when you're sharing with password managers is the ability to share passwords between users. There are scenarios, especially when you're in a development environment, you want to share keys, you need that ability. And with a browser password manager, that's just not there. You need to have the ability to recover passwords when someone's leaving the company to access their accounts. That's also a feature. Just the lack of organization or hierarchy. That's one feature that you need that is available with all the other providers on that same slide. How might social engineering attacks such as phishing attacks or impersonation be used to undermine security of end-to-end encryption and gain unauthorized access to data? So social engineering attacks, end-to-end encryption is just as prone to social engineering attacks when you're looking at it from the client side. But when you're looking at it from the service provider side, there the risk is slightly lower. So your data will only be leaked if you are socially engineered. And if your subcontractors are socially engineered, your data is still safe. So when you're looking at it from the attacker's point of view, they have to go against each and everyone independently to access their data. And there's no one golden trophy accessing a lot of organizations' data at the same time. So it's really just minimizing the impact of social engineering. It's not going to fix social engineering. Passwords by nature are a problem, and password managers are not a scalable solution. They are more like a patch on a bleeding wound. I would agree with that. Only solution I see is FIDO, but this technology is not widely accepted by the big three, taken over by Passkey, that does not fit all circumstances. What's your opinion about that? I agree with you 100%. FIDO does help, would help, so to say. I'm very, very sad that Microsoft does not support it in all scenarios. Google doesn't support it either. There's still a long way to go until FIDO is widespread, because FIDO, on the other hand, does protect against social engineering, or at least a lot of social engineering attacks like phishing. So it's phishing proof. That's great. But you still have to manage credentials. So FIDO together with SSO is probably the best. And what we see is that you should also be able to put some sort of cryptography into the identity, where you can use your identity to encrypt things and not just to authenticate yourself. That's one thing that that I'm personally missing from the FIDO framework. Have you considered what deployment of FIDO with pass keys would bring to your use case? Yeah, so this actually is exactly what I mentioned in the previous answer to the previous question, is that FIDO is really good for authentication, but not for giving a secure key to encrypt things. And that's where, for our particular use case, there would need to be done some workarounds where we store additional key on the device. Can you please elaborate a bit on secure compute platforms, meaning server-side computing on encrypted data without exposing it? Yes, I'm somewhat familiar with this technology. You still have to trust the hardware and the hardware manufacturer and the person controlling that hardware, and the fact that you can really authenticate that you're using that hardware. I see secure compute and HSMs as a step between classical computing, what I mentioned at the very beginning, classical IT security, and then you have these HSM solutions and trusted computing, which is one layer better, very good for auditing purposes. And then you have end-to-end encryption, which is the real guarantee of transparency from the server or opacity for the server, so the server doesn't see anything. The issue over here is also trust. There's one last question. Are there emerging technologies or trends that could pose a threat to the long-term viability of end-to-end encryption as a privacy security tool? Yeah, so of course there's quantum computers that is an issue when you're regarding public key encryption that is widely used today. But the solution to that is not far off. We have very good post-quantum algorithms in the race, in NIST's race. They have already been chosen. The final specification is hopefully coming out later this year. So just changing the public key encryption algorithms will fix the issue with quantum computers. And I think I've gone through all the questions.
Yes, I think so too. Time is already over. Thank you very much for your attention, Sylvester.